Hello everyone, let's start with the questions for today. First question for today is, Savvy and Harry are friends. Find the probability that both will have the same birthday and different birthday. Ignore leap year. So here we are simply given that we do not need to consider the leap year. So except leap year, how many days are there in a normal year? In a non-leap year, there are 365 days in a normal leap year. Now, Savvy can have her birthday in any one of these 365 days, and Harry can also have his birthday on any one of the 365 days. So, the total number of ways in which Savvy can have her birthday is 365, which is same as the total number of ways in which Harry can have his birthday, 365. Now, both the birthdays, so combination, how many combinations are possible for both of their birthdays? Means suppose Harry and Sally, they both can have 365 ways in each birthday. So the total number of ways 365 into 365. These are the total number of ways in which both of them can have their birthdays. Now, how many ways are there in which they have the same birthday? 365, right? There are 365 days, so there are 365 ways in which they can have the same birthday. Now, probability of having the same birthday is the favorable outcomes upon total number of possible outcomes. So, favorable outcomes is what are the number of ways in which they can have the same birthday, that is 365, divided by total number of possible outcomes, that is what are the total number of combinations that are possible for their birthday, that is 365 into 365. So, the probability of them having the same birthday is 1 by 365. Now, we all know the probability of occurrence of an event adding to probability of non-occurrence of an event is equal to 1 always, right? So, the probability of having a different birthday plus the probability of having the same birthday, we can write it in a different way also. Probability of having the same birthday plus probability of not having the same birthday. So, probability of an occurrence of an event and probability of non-occurrence of an event. Adding them together, we get 1. So, the probability of having different birthdays, probability of having the same birthday subtracted from 1. So, 1 minus 1 by 365, that is 364 by 365. So, this is the probability of them having the different birthday. Now, a letter is chosen at random from the letters of the word assassination. ASSASSINATION. Find the probability that the letter chosen is a vowel. Now, it is a very, very simple question. How many total letters are there in this word? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 are the total letters that are there in this word. Now, how many are vowels? 1, 2, 3, 4, 5, 6. 6 of them are vowels. So, the probability of having a vowel is 6 by 13. Now, consonant. How many consonant? 1, 2, 3, 4, 5, 6, 7. So, 7 consonants. So, probability 7 by 13. This can also, 7 by 13 can also be obtained by 1 minus number of vowels. So, 1 minus 6 by 13 is equal to 7 by 13. Simple question? Yeah. Next. A piggy bank contains 100 5 paisa coins, 50 1 rupee coin, 20 2 rupee coin, and 10 5 rupee coin. If it is equally likely that one of these coins will fall out when the bank is turned upside down, what is the probability that the coin will be a 50 paisa coin, will not be a 5 rupee coin? Now, pause the video here for a few seconds and try this question yourself. It is a very simple question. Let me discuss the solution also once. Let us discuss the first part, that is 50 paisa coin. Now, how many 50 paisa coins are there? 100. So, the number of favorable outcomes will be 100. Okay. Now, what are the total number of coins? 100 plus 50 plus 20 plus 10. So, 180. So, the probability comes out to be 100 by 180. That is 5 by 9. Okay. Now, second part is will not be a 5 rupee coin. Now, this we can do it anyway. If it is not a 5 rupee coin, then it needs to be 50 paisa coin, 1 rupee coin or 2 rupee coin. We can simply add them 100, 50, 170, 170 by 180. Okay. Or we can just find the probability of getting a 5 rupee coin, that is 10 by 180. And we can subtract it from 1. Then also we can get the same answer. Okay. Next question. A jar contains 24 marbles. Some of are green and the other are blue. If a marble is drawn at random from the jar, the probability that it is green is 2 by 3. Find the number of blue marbles. So there are total 24 marbles which are green and blue in color. Now, if green marble is drawn, the probability is 2 by 3. We need to find the number of blue marbles. Let G be the number of green marbles and B be the number of blue marbles. Total, there are 24 marbles. So G plus B is equal to 24. Now the probability of having a green marble is number of green marbles divided by the total number of marbles. That is G divided by 24, which is 2 by 3, that is given in the question. So solving this equation, we get value of G as 16. That is, we get the number of green marbles as 16. Now, G plus B are 24. So, the number of blue marbles that are left with us is 24 minus G, that is 24 minus 16, that is 8. So, there are total 8 blue marbles. Okay, now the next question is, a jar contains 54 marbles, each of which is blue, white or green. So there are 54 marbles which are divided into blue, white and green color. The probability of selecting a blue marble at random is 1 by 3. The probability of selecting a green marble at random is 4 by 9. How many white marbles are there? So total there are 54 marbles. Let blue marbles be B, G, green marbles G, white marbles W. Okay. So we know that B plus G plus W is equal to 54. That is probability now of getting a blue marble is number of favorable outcomes divided by total number of possible outcomes. That is B divided by 54. So that is 1 by 3. It is given in the question. So solving this, we get the value of B to be 18. That means the number of blue marbles are 18. Now probability of green marbles, G favorable outcomes divided by total, that is 54. Now it is given 4 by 9 in question. So 4 by 9 is equal to G by 54. Solving this, we get the value of G to be 24. So the number of green marbles are 24. Now B plus G plus W is equal to 54. So putting in this equation the value of B and G that we have just find out, the value of W comes out to be 12. So the number of white marbles is 12. Okay. Now there is one more way to do this question. We know the probability of having green marble 4 by 9, blue marble 1 by 3. Now the probability of getting any one of the 3 marbles, if we add them, it comes out to be total 1. Okay, because there are only 3 colors and we will get at least one color if we draw at random. So it is a sure event. So the total probability is 1. So 4 by 9 plus 1 by 3 plus probability of white marble is 1. Now solving this, we get the probability of white marble as 2 by 9. Also, we know that probability of white marble should be W by 54. That is favorable outcomes divided by total number of possible outcomes. If we equate these two values, we get this equation, and solving this equation, we get the value of W to be 12. So the number of white balls are 12. Let's see now next question. Two dice are thrown simultaneously. Find the probability of getting an even number as sum. So, when two dice are thrown simultaneously, this is the sample space that we get. These are the total possibilities. So, total number of possible outcomes in this case will be 36. Right, we are clear with that. Now, the first part asks us even number as sum. So, when we throw two dice, we need to get even number as sum. Like, let us take this first one. 1 plus 1, 2. That is an even number. So, this will be the favorable outcome. Now, it is a very easy way. Now, odd plus odd is even. Even plus even is even, and odd plus even is odd. Even are 2, 4, 6 and odd are 1, 3, 5. We all know that, right? So, if we fix the value of first dice 1, 2, 3, 4, 5, 6 line wise, then it is very easy question. We do not need to calculate every time. That is 2, this is 3, this is 4, this is 5. It will be a very long process if we start doing like this. So let's see. First, let us fix 1 on the first dice. So on what can be there on second dice? If you want an even number as a sum, then on the second dice it needs to be odd value only as for the first dice. If first dice is odd 1, then the second dice need to be odd so that the sum is even. So if we have 1 on the first dice, on the second dice what can be there? 1, 3 and 5. Now if we have 2 on the first dice, the second dice also should contain an even number. Even plus even is even. Now if we have 2 on the first dice, second dice should be 2, 4 or 6 for it to be a favorable outcome, for it to be the sum of the dice to be even. Now line wise we can do it for 3. 3 is odd, so we need to pair it with odd numbers. 4 is even, 5 is odd, 6 is even. Like this we can see these are the number of favorable outcomes. So how many total number of favorable outcomes are there? 18. So the probability is very simple. Favorable outcomes divided by total number of possible outcomes, that is 18 by 36, that is 1 by 2. So there are 50% chances, there is 50% probability that the sum will be an even number when we throw two dice simultaneously. Now let's see the next part. The sum as prime number. What are prime numbers? A number that is divisible by 1 and the number itself only. Like 11. 11, if we see the factors of 11, there are only 1 and 11. So this is a prime number. Okay. So let's see. How many prime numbers are there? 2, 3, 5, 7 and 11. So these are the prime numbers. When we throw a pair of dice simultaneously, what is the maximum outcome if we take the sum? The maximum is 12. Okay. So we need to see how many prime numbers are there below 12, less than 12. So there are 5 prime numbers below 12, 5 prime numbers less than 12. Which are those? 2, 3, 5, 7 and 11. Okay. Rest are not the prime numbers. So we need to see when we throw a pair of dice, how many possible outcomes are there in which the sum is a prime number. That is, the sum is one of these 5 numbers. So let's see. 1 plus 1, 2. Yes, it is a prime number. 1 plus 2, 3. It is a prime number. 1 plus 3, 4. No, 4 is not a prime number. 1 plus 4, 5. 5 is a prime number. 1 plus 5, 6. not a prime number. 1 plus 6, 7. 7 is a prime number. 2 plus 1, 3. 3 is a prime number. 2 plus 2, 4. 4 is not a prime number. 2 plus 3, 5. 5 is a prime number. 2 plus 4, 6. 6 is not a prime number. 2 plus 5, 7. 7 is a prime number. 2 plus 6, 8. 8 is not a prime number. So like this we can take all of them. We can simply cancel out the possibilities which do not give their sum as a prime number. So how many favorable outcomes are left after we cancel out all the non-favorable possibilities? 15. So the number of favorable outcomes are 15. Total number of possible outcomes are 36. So the probability that the sum of the two dice is a prime number is 15 by 36. If we cancel out by 3, we get 5 by 12. Now next is a total of at least 10. At least means come se come. Now at least 10 means 10 or more than 10. It can be 10, 11, 12, 13, 14, 15. But since the maximum possibility is 12, we can go till 12. So a total of at least 10 means there are only 3 possibilities. We desire only 3 possibilities as a sum, that is 10, 11 and 12. Now we have a sample space with us. We can simply cancel out the non-favorable outcomes and count the number of favorable outcomes that are left. Okay. So we can see if we have 1 on the first dice, the maximum, the sum goes to 7. So this whole possibility is cancelled out. Now if we have 2 on a first dice, the maximum possibility goes till 8. So this also is cancelled out. Now if we have 3 on the first dice, the maximum goes to 9. This also is cancelled out. Now if we have 4 on the first dice, the maximum goes till 10 and 10 is desirable. So yes, this is a favorable outcome. Now let's see just below 10, it is 9. 9 is not a favorable outcome. So we cancel it out till here. Now if we have 5 on the first dice, the maximum goes till 11. It is a favorable outcome. And less than that is 10. This is also a favorable outcome. Less than this is 9. This is not a favorable outcome. So this is cancelled out. Now if we have 6 on the first dice, we can see the sum is 7, not a favorable outcome. 8, not a favorable outcome. 9, not a favorable outcome. 10, yes. 11, yes. 12, yes. So these are the 6 pairs that are desirable, that can be counted as a favorable outcome. So the number of favorable outcomes are 6 and the total number of possible outcomes are 36. So the probability is 6 by 36, that is 1 by 6. A doublet of even number. Doublet means same numbers. If we see the sample space, there are 6 cases which are same number. Let's see this one only. This 2 by 2, 3, 3, 4, 4, 5, 5, 6, 6. These are the doublets, pair of doublets. Okay. Now even doublets, even numbers, that is 2, 2, 4, 4 and 6, 6. So there are 3 possible favorable outcomes. So the probability is 3, the number of favorable outcomes divided by 36, total number of possible outcomes. Cancelling by 3, we get 1 by 12. A multiple of 2 on one dice and a multiple of 3 on the other dice. What are multiples of 2 that are possible? 2, 4 and 6. 8. No, dice contains only till 6. And the multiple of 3, 3 and 6. Simple. So we need to see that there is a multiple of 2 on one dice and the multiple of 3 on the other dice. So let's see. Let's go line wise only. The first line contains 1 on the first dice. Now 1 is neither the multiple of 2 nor a multiple of 3. So this whole line gets cancelled out. Okay. Because on one dice there is a multiple of 2 needed and on the other dice there is a multiple of 3 needed. Now next line, let's see. it has 2 on the first dice. Now if 2 is there on the one dice, the other dice should contain a multiple of 3, that is 3 and 6. Okay, so there are 2 possible favorable outcomes that are left, 2, 3 and 2, 6. Now if we have 3 on the first dice, the other dice should contain a multiple of 2. We have a multiple of 3 on one dice. Now we need a multiple of 2. So if we have 3 on the first dice, what are favorable possible outcomes? 3, 2, 3, 4 and 3, 6. That is on a second dice we need a multiple of 2. Now if we have 4 on a first dice, it is a multiple of 2. We need a multiple of 3 on the other dice. What are multiple of 3? 3 and 6. So in this whole set, these two, 4, 3 and 4, 6 are the possible favorable outcomes. Now if we have 5 on the first dice, 5 is neither the multiple of 3 nor a multiple of 2. So this whole line gets cancelled out. Now if we have a 6 on a one dice, 6 is both a multiple of 2 as well as a multiple of 3. So on the other dice, on the second dice, we can have a multiple of 2 and or a multiple of 3, and it will be a possible favorable outcome. If we have 6 on the first dice, the second dice can contain 2, 4, 6, or it can contain 3 and 6. So the number of favorable outcomes is 6, 2, 6, 3, 6, 4 and 6, 6. So the total number of favorable possible outcomes are 11. So the probability is 11 by 36. 36 is the total number of possible outcomes. Okay. Same number on both sides, doublet. I have just told you what is a doublet, so you can try it by yourself. The answer will be 1 by 6. A multiple of 3 as a sum. Try it by yourself. Write the sample space neatly. Cancel out the non-favorable outcomes and then just count the number of favorable possible outcomes, and the probability will be very easy to find.